May I have your attention, please? The following is not the real Jeff Foxworthy.
If you have lost more than 5 hive tools and your lawnmower has found 2 of them, you might be a beekeeper. If you talk to your bees more than you talk to your spouse, you might be a beekeeper. If you think that Varroa mites were created by Satan himself, you might be a beekeeper.
Welcome to Bee Love Beekeeping podcast, presented by our friends at Man Lake. Special thanks goes out to the not real Jeff Foxworthy for that fun intro. And by the way, Jeff is getting a little thin on ideas for upcoming episodes. So if you can think of fun things that make you a beekeeper, please send them our way. Send to Eric at beelovebeekeeping.com. Now today we're going to have a really interesting interview on kind of a scientific level, but you've been forewarned of that now, about a new treatment for Varroa mites. First, a little bit of news from the beekeeping world, and this really isn't new, but it's in the news right now, and that is some new things about Apitherapy or Bee Venom Therapy or BVT, whatever you want to call it. Now, this is a subject I happen to be really interested in. I don't know enough about. I've done a bunch of research, but I still feel like there's a lot to learn. And maybe that's just because a ton more research needs to be done still. So if you're not familiar with Bee Venom Therapy, let me just read you a little bit of background here. Bee Venom Therapy, also known as apitoxin therapy, is an alternative treatment that uses bee venom to treat various diseases. Bee venom contains substances that may have anti-inflammatory, analgesic, antimicrobial, antiviral, and anti-cancer properties. I read some studies this last year about how bee venom has been successfully tested for breast cancer. There are studies out about Lyme disease, about MS, but I can tell you, and I am not a doctor, and if you go to your doctor, he or she probably knows very, very little about this. So it's really up to you to do your own research, figure out for yourself what you want to do, if anything, on this topic. I have done some of it myself, and I got to tell you, even though I've been stung a lot by bees, the first time you grab one with a tweezer and hold it to a specific spot and ask it to sting you, it is harder to do than you would think. It seems like everything in your human DNA is saying, don't sting, don't sting, don't sting. And then once you do get stung, most people will tell you, for the full benefit of it, you need to leave that stinger in for about 15 minutes until it has finished pumping all of the venom. It actually hurts that whole time. All right, let me get back to what this article is saying. Bee venom therapy is used to treat a variety of conditions, including musculoskeletal diseases such as arthritis, gout, bursitis, tendinitis, lupus, etc., central nervous system diseases such as Parkinson's and Alzheimer's, cancer, I just mentioned breast cancer a minute ago, HIV, chronic Lyme disease, and there are many others. Now, if you're a beekeeper, it's not very hard for you to grab a bee or two and sting yourself. In the winter, it's a little bit more difficult opening up a hive that you don't want to open up in 20-degree weather. And for the average person that is doing bee venom therapy, they have been through some kind of a training course, and they are ordering their bees from beekeepers. So they're getting, and I'm looking here at the average price. Looks like people are buying a box of bees for about $20, and that can have 50 or 60 bees in it. Many people need a box or two a month. Here's something that I didn't know, and that is that there are now stinging influencers. So TikTok, Instagram, etc. There are people out there that are, quote, stingers, and can tell you all about this. So that's one place to look. There are medical journals. There are all kinds of places to look up. There are companies such as Heal Hive and others that will train you on how to do bee venom therapy. Bottom line, again, I'm not a doctor. I'm not giving medical advice. Don't sue me. But there is something to this. There is something to bee venom therapy. Now, if you know an expert out there, I would love to get somebody on the show, have them reach out to me, eric@beelovebeekeeping.com. Now, let's go ahead and change the subject. In today's interview, we're going to be talking with Justin Sanchez from Terra Vera about possibly a breakthrough in Varroa mite treatment. So let's get right to that. I am so happy to welcome to the show today, Justin Sanchez from down in Albuquerque. How are you today, Justin?
I'm doing outstanding. How are you doing, Eric?
Good. It is good to see you again. Our pre-interview the other day, I enjoyed so much because anything that might help me and other beekeepers get a handle on Varroa, I am all over it. I want to learn about it. I want to tell people about it. And that's everybody. That is what Justin is doing here today. Tell us just very briefly about your company and how you got into this angle with honeybees, because that's not where you started, right?
It's not where we started at all. So thank you, and I appreciate the opportunity to talk a little bit about the company. We founded Terra Vera back in 2000. Right about the time that the country shut the economy down due to the global pandemic. But we had been working, and I'd been working in my career for a while on oxidative technologies. And when you think about an oxidant, those are things like chlorine dioxide, bleach, ozone, things that can be useful, but that also have a lot of challenges associated with using them because there can be safety issues associated with them. And they have different unintended consequences as well. And so having worked on oxidative technologies for a long time, we came to a spot where we knew we needed a safer oxidant for any host of reasons. And we sort of stumbled upon some work that had been done in immunology in the past, and we figured out a way to generate the chemistry that now finds itself into both our indoor ag applications as well as beekeeping, a way to generate it electrochemically. And so that's sort of a really fast intro to where we are, where we started. Our initial focus when we started Terra Vera was on indoor agriculture. We were looking to help solve plant diseases, yeasts, molds, powdery mildews, that type of stuff on indoor agriculture, as well as some outdoor agricultural plants, with a really safe alternative. Our blends use only food grade salts, amino acids, and sugars. We take them, we blend them together, we activate them, and we convert them into an oxidant for a short amount of time. All oxidants try to steal electrons from the environment, and so that's how they work on pests such as yeast, molds, powdery mildews. We had customers reporting back though that it was working on spider mites in some of their indoor grows, which, to be honest, at the beginning I didn't necessarily believe when they first reported back. And after we did some lab studies, we found out it was really effective on some softer body pests such as spider mites, aphids, and then it took us only a fraction of a second to find a lot of pool in apiculture for helping deal with what's a really transformative issue.
Okay. Before we get too scientific or too far down the road, let's back up just a little bit. We had a recent episode with the people from Dallin talking about the bee vaccine. Today we're talking about a completely different thing. This is not a bee vaccine. This is something that specifically is for controlling Varroa, and there's a nutritional factor as well. So you just mentioned that oxygenate, is that the proper term?
It's an oxidant.
Oxidant. Okay. Please tell us what that means in English for those of us that don't have a science degree.
Sure. Oxidant is a broad category of chemicals. Common examples that folks usually are aware of are like hydrogen peroxide or bleach. The challenge with hydrogen peroxide and bleach and some of those other oxidants is they're extremely reactive. what they try to do is they try to strip electrons from the environment. And by doing that, they change sort of the chemical nature of whatever they're stripping electrons from. And sorry, you have the nerdy technical guy, so I always have a tendency to take it that direction.
I'll keep reining you back in.
But that's sort of how they work. This oxidant, if you looked at it in comparison to how strong the oxidant is, this is a fraction of the strength of hydrogen peroxide or bleach, but it has just enough oxidative potential to be able to interact with some of these organics, like a powdery mildew, like a Varroa mite, and activate it and not have negative effects on the bees or the humans or the honey or other things that might be present in the hive.
Okay, you've mentioned the word bleach a few times. Are you recommending I stick bleach in my hive? Because I don't want to do that.
I'm not recommending you stick bleach in your hive.
Thank you.
Yeah, absolutely. Again, it's like saying that, water and alcohol are both liquids, right? It's the same thing as saying bleach and our product are oxidants. They're very different, even though they fall into the same class of compounds.
I just didn't want to scare people away from this at all.
No. Not at all.
One of the things that I love about this, and we're going to get into this in a minute, is how safe it seems, at least from what I know so far. Because most of us beekeepers, we don't want to put chemicals into our hives. We don't want to treat bees with some foreign thing to kill a bee that's on another, a bug that's on another bug, because that hurts the bug that we like the most also. And that's what got me excited about this, because it seems much safer than a lot of the treatments out there. And, I don't want to get any phone calls from those companies, please. We're not making comparisons yet, but this gets me kind of excited. Let's talk about how you're going to deliver this oxidant to the bees. And then we'll talk about Varroa a little bit more and how it affects them. So how do you deliver this?
Sure. So what we have is we have an apparatus that sits on top of a hive. It's a fogging apparatus, and it's also an activator apparatus. So what we do is you open up a hive, you set this on top of your hive, and you pour in a blend of food-grade salts and amino acids. Again, these are all things that you can consume. These are things that you could buy. You could buy at a local GNC or on Amazon that are labeled for human consumption. Every single one of them. So you would pour those into the reactor. You hit a button, and the reactor converts that weak amino acid solution into a weak oxidant solution. That oxidant solution doesn't last very long. By the time it dries, it goes back to the amino acids that it started with. And so you activate it. It then is fogged into the hive. We have a disc with 12 piezoelectric actuators that make a very fine mist, and then fans that recirculate that through the hive to be able to get into all the nooks and crannies. It's a contact thing, so that the mites that come into contact with it, they tend to expire very quickly on the order of minutes. And then as both the oxygen is consumed as well as it dries up, it goes right back into being food-grade salts and amino acids that the bees can use. The other thing is most of our blends for bee solutions actually don't actually have salts. They have a sugar. I keep saying salts. I mean sugars. That's a carryover from our indoor ag stuff. We've replaced the salts with the sugar, so the bees do get, for our nutrient blend, they get a carbohydrate boost associated with when they groom, they consume some of it. We've seen them consume it directly in the hives. We've actually run some studies where we fed bees it, and they've done quite well. We've done cage studies. We've partnered with some leading researchers to do that type of work to make sure we're not having negative effects on queens, negative effects on bees or larva pupa or eggs. The bees do quite well with it.
When I use an oxalic acid vaporizer on my hive, that's supposed to be something that's, quote, safe for bees. Yet the instructions are to wear protective eyewear, to wear a big respirator, because you don't want to breathe that stuff. It's going to hurt your lungs. And my brain's going, if that's going to hurt me, it can't be good for the bees. How is this different? Or do I need that protective equipment when I use your machine also?
You don't have to have any protective equipment beyond what you need for protecting yourself from the bees. So, just your standard bee suit. Again, we've treated now well over 1,000 hives doing some of our pilot work and getting spun up to bring this to the market. I spent this entire summer, or at least half this entire summer, in a bee suit. It was a lot of fun. Had a ton of great experiences. It's new to me. I got stung for the first time here in March of this last year. But there's no additional PPE required. It's not something that you need a respirator or anything like that.
I've seen the videos on your website. You showed me another one as well. Basically, this looks like, if I can help people imagine it, take the lid off a hive, put on this, it almost looks like an umbrella kind of thing, put the formula in, and it turns it into fog, and you can actually see it coming out the entrance in the bottom.
You can.
Right? And that's how you know it's getting everywhere in the hive. How long do you need to leave that on the hive and running?
That's a great question. So our current product, the product that we're looking to launch, is geared more towards hobbyists and sideliners. It takes about 4 to 6 minutes per hive to treat the hive. We know that's not fast enough for commercial large-scale operations. We have designs in the works to be able to scale up. That's all engineering work. It's adding an additional disk and additional power and making sure that we can do the activation fast enough to where we can get that down to sub 1 minute per hive. But the device we're launching right now, and it's about 4 to 6 minutes a hive.
So, and this is super new. I couldn't even buy one today yet, could I?
You can't buy one today. There's we have several prototypes that we've built and used and tested as we are getting to the kind of the final design for what we will put on a hive. We have one quantity of one unit that will be at the show here in Kentucky shortly. That device has everything integrated into it, and it's very close to what the final device will be. We're right at the stage now where we are tooling up. We're getting quotes for large-scale volume quotes, and we're really looking for the market to help us a little bit understand what sort of interest and what sort of volumes we might expect, because that influences a lot of our manufacturing decisions.
By the way, this episode probably won't come out until right after the Honeybee Expo, so hopefully some of the people that are listening also saw some kind of a demonstration there as well, and you've already answered some of their questions.
Great.
So they're probably more of an expert than I am at this point.
Okay.
You keep talking about how safe this is. Can I use this with honey supers on?
Yes. Yes is the short answer.
Yes is the short answer. It's not going to affect my honey in any way, shape, or form.
No, and in fact, one of the questions that we had was because the chemistry, you can taste it. It actually tastes a little bit like a Sour Patch Kid candy. So we were concerned actually that it might have a taste issue or might change some of the taste of the honey. We did not observe any of that. We ran side by side with honey that was treated twice a week or honey that was not treated at all, and couldn't tell the difference.
Okay. You're doing a great job at answering these questions succinctly. I'm going to run out of them pretty soon.
Do you want me to? I mean, I can get more verbose, or
no.
Let me know.
No, I don't want you to get too technical. I do want you to talk though about Varroa.
Sure. And
why this is going to affect Varroa and not hurt my bees.
Yeah, this is a great question, and I get it a lot, and it's very counterintuitive. I mean, it's funny. One of the things I've noticed the most, that I've been the most impressed about as I've interacted with a lot of beekeepers over the last year is how smart the questions are. Because that's a really good question. Well, why would this affect mites and not affect bees? And the answer is the mode of action that we think that this works. As I mentioned before, this is an oxidant. It tries to steal electrons from the environment. Harder shells of organisms, like a bee has, a pretty solid exoskeleton, they don't give up their electrons easily. The things that give up electrons easily are like soft body tissue. So you can imagine, everybody has their sort of own experience with this. If you imagine that you accidentally sprayed a little bit of bleach in your eye, that's very different than you spray a little bit of bleach on your hand, right? Your eye is a soft body tissue. It will hurt. It can damage that a lot easier than it can something that's more robust structurally, like your hand. Mites have a much higher surface area of soft tissue to hard tissue than bees do.
let me just take a minute here to thank our presenting sponsor, Man Lake. I've been asked, does Man Lake provide equipment for commercial beekeepers? Yes. Do they provide equipment for sideliners? Yes. How about beginners? Yeah, of course. Protective gear? Yes. Queens, nukes, and packages? Yes. Processing equipment? Yes, yes, and yes. There is a reason that Man Lake is the #1 supplier for thousands and thousands of beekeepers. In fact, I could give you 100 reasons to try them, but let's start with just 10, as in $10 off your first $100 purchase with the discount code MLBLOVE10. Don't worry, it's all in the show notes. Seriously, you'll be happy you gave Man Lake a try. And now, back to the guest.
So bees do have soft tissue, so do humans, so does everybody. But the ratio of those tissues is dramatically different. And so what happens is you're able to, at specific dosages, overwhelm the mites and not have any effect on the bees. I'm sure there's a concentration. We haven't gotten to it yet in any of our testing. In fact, we've tried to over-test this on bees. I'm sure there's a concentration of active chemistry that it would have a negative effect on bees. I'm sure there was, if you took it up to 20%, and again, we're dealing with the 0.05% range that we have active chemistry. I'm sure if you took it up that high, it would have some effect. But at the concentrations that we're putting into the hive, again, it has no effect. And in fact, the effect that we have seen is very beneficial. So when we fog a hive, and let me tell you, the first time I fogged a hive, I was really nervous. So I was still kind of new to beekeeping, right? And I was actually by myself. I gotten decent enough that I felt good enough that I could at least do that sort of stuff. And we had several developmental hives that we were kind of testing out the chemistry on. And I just knew I was going to get swarmed and stung. I felt it in my bones. And actually the opposite happened. The bees were more agitated by the fact I took the top of the lid off and put the fogger on. Once we started fogging, the bees actually calmed down. What we actually have observed is they groom each other. It's a lot like if you were to use a sugar spray and spray a bee like almost as a smoker. I know some beekeepers do that. That's sort of the effect that we get once the fog is turned on. So it creates a very calming effect. And there's limited data. One of the things I'll say is we're a year into this. We've run a lot of field trials. We've had a lot of researchers look at this, but we're still learning a lot. We don't claim to have all the answers. We just believe we can be a part of the solution, given everything we've learned to date. But in one of our field trials, or one of our cage trials of adult bees, we actually saw that when we sprayed the bees with our nutrient solution and we were spraying them every day and overspraying them versus water, the bees actually tended to live a little bit longer. And again, these are limited trials, but tended to live a little bit longer that we were spraying. And at the end of the day, you'd expect that a little bit because there's nutrients, there's sugars in our solution. There's also amino acids that have been proven to help with bee health. I didn't talk about it a lot at the beginning, but the amino acids we've chosen in our blends were chosen specifically for bees. And a lot of this work is not ours. It's published by third-party peer-reviewed researchers. 2 of the amino acids that we use in our nutrient blend have been shown to improve bee cognition. So both acquisition of memories and as well as the ability to retain those memories for a longer period of time. Now, it's a very deep or a very intense, technical article, but that's sort of the Reader's Digest summary. Another one of the amino acids we use is a very important constituent of some of the more important pollens that bees use, some of the more wildflower type pollens. And so we've chosen those amino acids specifically because they're easy. They should be easy for the bees to use and synthesize into things that they can use in their bodies.
So tell me if I've got this straight from how you were explaining just a minute ago about Varroa mites. You have found a weakness in them in that they have soft tissue on the outside. So are these amino acids being absorbed then through, I don't know if you call it skin on a mite, but through their outer shell? Or is it something they breathe or eat or what?
I think it's a combination of those. I think it's a combination of they breathe it, they get it on their skin. To inactivate them, I think it's a series of those things. I think it gets on their foot pads. That's sort of a phenomenon as well. I think it's all of those. in combination.
I know you haven't done a ton of research yet, but give me some idea of Hive A, for example, if they had 5% mite load and then you treated them with this fogger and then a day or two later you tested them again, can you give me an idea of the difference that you saw, the results?
Sure. I'll answer the question in a slightly different way, maybe, and you can bring it back to what you're talking about, and make sure I answer the question that you're asking. The most in-depth field trial that we did was sort of towards the end of the season here in New Mexico. There was a limited number of hives, 12 hives, and we ran it over the course of about 6 weeks. And we did a lot of analysis on pre and post fogging, what mite counts did over time. We did full hive breakdowns and, looked at adult bee populations and hive weight and all that sort of stuff. And the key conclusion out of that was as follows. We didn't treat some hives, we treated other hives. The survivability over that period of time, and all of the hives started with about a 4 to 5%, sometimes a little bit higher mite load. So they were on the kind of borderline range. All of the hives kind of had that when we started. The hives we treated had a 4 times higher survivability rate than the hives we didn't. We had several hives, and again, not a ton of hives. So this is not statistically significant, I'll tell you that right now. But also very encouraging. The hives that we did not treat, we had several of them just collapse. The hives we did treat, they seemed healthier, they did better over time. Now, you talk specifically about mite counts. We were testing smaller hives, so we didn't do a ton of alcohol washes on those hives. We did an alcohol wash about once a week. And so we did see the hives that we treated, they tended to bounce around a little bit, and towards the end of the study, they were all headed down. A lot of the reason for that is, and this is a question I'm sure was about to come up, our chemistry does not get underneath the capped brood. When we would treat a hive, all the adult bees that had mites on them, we would get rid of those, but then we had to wait for the emergence of what was already under the capped brood to be able to treat those again. So we treated once or twice a week for 4 weeks to try to get the population under control of mites. The most direct measurements that we did pre and post were sticky boards, mic drop sticky boards. So we would put a sticky board in 24 hours prior to treatment. We would take that out. We would put another sticky board in, treat, and then take that sticky board out 24 hours after treatment. And we typically saw between a 6 to 8x increase in mites post-treatment as opposed to mites pre-treatment. We think we can do a little better than that. We're still optimizing the final parts of the device. We've made some changes since then. We played around a little bit. So we're a little bit stuck because here where we're based in New Mexico, we can't do treatments through the winter. And so we've gotten to that point. We still think there's a little ways to go, but we were very encouraged by that. A couple other things we saw over that field trial is, for whatever reason, the hives that we treated seemed to show increased propolis. There was a lot more propolis in the hives. They were sort of stickier inside of the hive. We saw better populations in general, and we also saw better attitudes. The bee aggression seemed to either stay calm throughout the trial or got better throughout the trial.
I'm trying to take a guess in my own mind why there would be more propolis inside the hive. Do you have any theories on that?
I do not.
Huh.
I really don't. It was an observation.
I mean, we know how good propolis is for the bees. And so, wow, that's really weird.
It was an observation. We were working with, thank goodness, his name is Craig Norlander, a beekeeper here in New Mexico. Incredible. I mean, he was the former president of the New Mexico Beekeepers Association. Really, really experienced guy. Thank God we had him. He was the one who noticed it. And then when we actually started paying attention to it, it was very clear.
I find that fascinating, and I don't know why it's happening. So I assume this would work on other mites too, if we start getting overrun with trophy mites one of these days.
Yeah. So I'd mentioned we've worked with some of the leading researchers in the field. We were able to get Dr. Ramsey out of Colorado to take one of our systems, and it's actually one of the systems we had developed for indoor agriculture with some of our bee blend, and test it against trophy mites in India. and it's actually exceptionally effective on those mites. On contact, we have some videos of that that are on our website. They'll stop moving within a matter of seconds upon exposure to our chemistry. Again, the challenge for trophy mites and our chemistry is trophy mites spend most of their lives underneath the cap. And our current version of our chemistry does not penetrate the cap. We are doing work right now, and we're doing research right now to see if we can change that on a future blend. But that's work that's going on right now. We think we have a path to do that. We're very excited about it. But that won't be for another year or so. Well, hopefully you'll have me on one of these days to talk about that and how that works.
That'll be fun. I know we're very early in this whole process, and we don't want to jump to too many conclusions, but it just all makes sense to me. So I really hope that it works out well for you and that you find success in further testing and that this thing is going to be on the market pretty soon. I know I'd love to try one.
Well, we're right now on our website, we're doing some crowdfunding to try to accelerate the launch of this product. And so we're taking early sales or early pre-orders. So if folks are interested, they can find all the information on that on our website. It's terravera.com. Yeah, we'd love to hear from folks too. You can sign up for our newsletter, sign up to follow our crowdfunding launch of this product, of this initial product for sideliners and hobbyists. I will tell you, I had more fun in the last year of my career than I can say that I've had in a long time. And a lot of the reason is, the community, and it's just a fun community of people. Every beekeeper I've met is interesting and interested and engaged in trying to help solve this problem and understand what's going on in their lives. And so it's been a real blessing to me.
That's really cool. Okay. I forewarned you of this, and I know you haven't been a beekeeper for a long time, but you spent a lot of time with bees last summer. Any kind of wild and crazy stories that you've had beekeeping?
Yeah, so thanks for giving me a little bit of a heads up, because you gave me a chance to kind of crystallize some thoughts on it. I had not been stung ever in my life. I'm 48 years old. I've never been stung my entire life by a bee. Obviously, if you're going to get into hives and kind of mess with them, you're going to get stung. That's just the way that it's going to go. So I got stung for the first time this last March. Thank goodness I'm not allergic at all, really. But, when we were doing the field trial, we were really getting in the hives, and we were photographing every frame, front and back of each frame, doing alcohol washes, doing measurements of, the percentage of brood that's capped versus uncapped. I mean, really in-depth hive analysis. And we had one hive, and I never knew this before this year. We had one hive that just was different. It just had a different attitude. The bees were aggressive. They were grumpy. Every time you open the hive, they'd come after you. So I used to always dread doing that hive, when we do the full analysis on it. And so, it was probably the third time we had done, we pulled that hive apart and took it apart. We're there working on it. And somehow one of those girls got up my bee suit, up my leg. And I felt her right about my inner thigh. And I swatted her so hard, I gave myself a big bruise because I didn't want her to go any further. I didn't want to get stung any further up. But I actually gave myself a pretty decent bruise. The moral of the story on that hive actually ended up becoming a lot less aggressive as we treated over time, but which was great to see. But yeah, that was probably that's actually when I also invested in a slightly better bee suit to make sure that, we were getting so involved in those hives that it only made sense.
By the way, the very first time that you were stung, what surprised you about it? Was the pain level what you expected?
It was about, I guess, I just didn't really know what to expect. It was about what I expected. It actually stung me on the head. And one of the gentlemen we were there at the hives with, extremely experienced and very well-known beekeeper, Dr. Jeff Pettis, and he warned me. He had his veil off, and I took my veil off, and he said, "We need to put our veils back on. There's an angry bee here." And I was like, "How would he know there's an angry?" Because then he learned how to hear it. I didn't know yet how to hear that, and so I started to put my veil back on, and she bit me right behind the ear. It hurt, but it was the next day I didn't even have a welt, so I'm kind of blessed that way. I don't respond to them super strongly.
Oh, that's really good. And I hope you don't mind me correcting. Stung you, not bit you.
I'm sorry. Did I say bit me? Yes. Thank you for correcting me. I don't mind at all.
You'll get all the lingo down soon enough.
Yeah.
Hey, is there anything else, any other wisdom you wanted to impart on us before I let you go?
One of the things, Eric, that we struggle with a lot is it just doesn't sound believable. It's one of the big challenges that we have. And we get it in this market with beekeepers and spades. It just doesn't sound believable. How can you take food grade, salts, amino acids, sugars? How can you take those things and convert them into something that is toxic to these mites or to these organisms, but they're safe for me? And I like to answer that question two ways. The first way is your body, your immune system actually generates this exact chemistry or very, very close to it. And your body uses what it has. It uses amino acids, it uses proteins, it uses salts, it uses sugars. And it makes chemistries, and it actually makes this exact chemistry in the presence of invading microorganisms to inactivate it. And then what it goes back into, we really stole the reaction kinetics. We stole all that from the human immune system. So we just generate the chemistry differently. We don't generate it cellularly. We generate it with electrochemistry. But it is essentially the exact same chemistry. The other way, and this is kind of the trade show thing that I've done a couple of times. In one of our indoor ag trade shows, we actually took a bunch of plants that were infested with aphids. And aphids have a ton of soft body tissue. They're extremely susceptible to our chemistry. And so what I would do is I would make up the chemistry, I would activate it in front of a grower, had a microscope with the microscope image projected up on a big screen. And I would take the aphids and I would put them, I basically put them on a petri dish. You could see them on the big screen. I'd let the grower go ahead and spray it, and watch the aphids just stop moving and eventually turn into sort of a mushy goo. But then I would turn around and spray the chemistry on my hand, taste it, put it on my face. And, if you think about it, right, we are, as humans, we're used to pesticides or things that do, inactivate microorganisms. We look at them as, well, gosh, if that's really dangerous, I can't do that. And that's a good instinct to have. And that's why it's hard to believe sometimes, because this chemistry really has the best of both worlds. It can inactivate those microorganisms, but it can be perfectly safe for you.
That is unusual, and it is hard to believe until you understand some of the science behind it, like you've explained. To me, it makes sense. Again,
I find it a real blessing to be in this market, and I'm looking forward to meeting a lot of new beekeepers and helping to make a difference.
Great. Justin Sanchez, thanks so much for being on with me today.
Awesome. Thank you, Eric.
Thank you so much for joining us here on Bee Love Beekeeping, presented by Man Lake. Please, right now, before you forget, hit that follow or subscribe button and be sure to share this podcast with a friend. Remember, if you're not just in it for the honey or the money, you're in it for the love. See you next week.